Fabulous. Okay, so Bellringer says that we have to complete the BCA table if 26.9 grams of KCl are produced. So I can just put 26.9 grams into the table, right guys? No! Why not? It's not moles, right? The only unit allowed inside a BCA table is what? Moles, okay? So we have to convert grams to moles. We have what we know, over 1 times a conversion factor. Units on top must come down. So if we have grams of KCl on top, we need grams of KCl on the bottom. Now we can go ahead and pick our conversion factor. We're going to be picking this conversion factor, the second one, because it's the only one that has grams in it. And we need to figure out the molar mass. To calculate the molar mass, simply going to look up the molar masses on the P table for potassium and chlorine, add them together, we get 74.55. So, looking at our conversion factor, if grams is on the bottom, how many grams? The molar mass of KCl, so 74.55 grams. Don't split the brothers, right? We want to have one brother on the bottom bunk, the other brother on the top bunk. Multiply across the top and across the bottom to get a new fraction, then divide the top and bottom, and you end up getting 0.36083, blah, 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 blah. A lot of extra numbers after that. Keep 4 to 5 digits. That should be good enough so that you're not over-rounding things outside of the table, okay? So this is how much KCl was produced. We're going to go into the table with that number. Which one of these boxes is going to show us the produced amount of KCl? It's going to be this box right here, right? We have made 0.36083 moles of KCl, right? Okay, because it's a product, we know that we're going to be starting with no product, right? So before we bake brownies, we don't have brownies. So we have 0 moles before the chemical reaction takes place. And then we just combine rows B and C to get row A. So 0 plus this is the same number. Our reactant, we know it doesn't say anything about excess reactant. So we can assume that it reacts to completion, okay? So we assume that it reacts to completion. We have 0 moles. Now we're going to start filling out row C. Oh, wait, I can also fill this out, right? It's a product. We know that we're not going to have any product, okay? All right, now we can start filling in row C. Remember, C is for chemistry, but memory trick is calculating with coefficients. We're using the coefficients to help us calculate this row. So looking at the coefficients of KCl and KClO3, you can see that is a 2-to-2 ratio, or 1-to-1. So that means whatever amount of KCl produced, we will produce the same, or we will need the same amount of KClO3, because it's a 1-to-1 ratio. But instead of creating 0.36083 moles, we are using that many moles because it's a reactant, okay? A little bit of simple algebra here. What minus this number is 0? The same number, because we are assuming that it's reacting to completion. And now we have to figure out this last box. Now, this might be a little bit less intuitive than the other ones that you have done in the past, just because it's a 2-to-3 ratio. So you have to use a conversion factor. We're going to be using the molar mass or the mole ratio, okay? You're using the coefficients to calculate row C, right? So when we're looking at row C, we are starting with what we know, which is 0.36083 moles of KCl, right? Put this over here. Units on top must come down. So if I have units of moles of KCl on top, I need moles of KCl on the bottom. I am trying to get to moles of O2, so I'll put moles of O2 on top. Remember, we're using the coefficients to help us calculate row C. So what's the coefficient in front of KCl? It is 2. So we put 2 on the bottom because that's the coefficient in front of KCl. 3 goes with oxygen because again, that is the coefficient that is in front of oxygen. Multiply across the top and across the bottom, divide the top and bottom to simplify the fraction, and we end up with 0.54125 moles of oxygen. This is what we can put into the table for oxygen, and because it's a product, we are actively making it or creating it, so we put a plus sign in front. And then, of course, just to get row A, we combine rows B and C, simple addition, and end up with the same amount that we created. That is our BCA table. Raise your hand if you got it correct. Good job, you guys. Okay. The bonus question, if you got around to it, we are asked to determine how many moles of KClO3 are required to react. We're starting with moles of KClO3. We need to find grams of KClO3. So moles on top, moles on bottom. We're going to be using the molar mass conversion factor. So that means we also need to calculate the molar mass of KClO3. So Kc, K and Cl plus 3 oxygens is 122.55 grams per mole. That is what goes on top because we're trying to get to grams. Your final answer, once you multiply across the top and bottom, unrounded is 44.2197. We need to round according to the rules of sig figs. So look back at the number we were given at the very start of this entire ordeal. This has 3 sig figs. So our final answer should also have 3 sig figs, which gives us 44.2 grams of KClO3. Raise your hand if you were able to get that bonus question. Good job, guys. Okay. Does anybody have any questions for me about the Bellringer before we take our quiz? Emily.
So when you're finding how many grams from, like, you're going from the moles and you put the moles on the bottom and the grams on top, you want to make sure that there's 1 mole is equal to that many grams?
Yes, so remember, you are using the conversion factors that have been given to you. If you look at the conversion factor, it tells you what number moles. So for every 1 mole, and that's your molar mass. Okay, remember the definition of molar mass is how many grams of substance are in 1 mole of substance, okay? Other questions about today's Bellringer? Okay. Go ahead and